Hello everyone. Welcome back to the another lecture in this igneous petrology series. In today's lecture, we'll be discussing about the Bowens reaction series. Okay, so we'll be discussing about the Bowens reaction series. So Bowens reaction series is very much important when you are studying the igneous petrology, because Bowens reaction series tells us or properly explains how the mineral starts crystallizing when the magma starts cooling. Okay, so one more time I will repeat. Bowens reaction series explains us the way the minerals start crystallizing in a sequential pattern when the magma starts cooling down. Okay, so from that point of view, this Bowens reaction series is very much important in igneous petrology. So Bowens reaction series was introduced, okay, by a Canadian. Okay, it was introduced by a Canadian petrologist. Okay, so petrologists are the uh, scientists who study about the rocks. Okay, so it was uh, invented by a petrologist, that is a Canadian petrologist by the name Norman, by the name Norman L. Bowen. Okay, so when did he introduce this? In the early 20th century. Okay, so in the early 20th century, a Canadian petrologist by the name Norman N. Boyle introduced the Bowens reaction series. So, this Bowens reaction series tells us the sequential way how the minerals crystallize when the magma starts cooling down. Okay, so this is just the introduction part about the Bowens reaction series. So this Bowens reaction series helps the geologist to understand the mineral composition of the igneous rock as well. Okay, so to understand the mineral composition of the igneous rock as well, this Bowens reaction series is very much important. Okay, so you will be seeing what does this Bowens reaction series consist of. Okay, so I have drawn the flow chart here. So we will be just entering the minerals here. Okay, so this Bowens reaction series consists of two series. Okay, so on the left hand side we are having one series that is known as the discontinuous. Okay, so we are having the discontinuous series at the left hand side and the continuous series and the continuous series on the right hand side. Okay, so the magma will be in the molten state. Okay, so magma will be in the molten state. Okay, it will be in a molten state, but it will be consisting of all the silicate group of minerals. It will be consisting of all the silicate group of minerals. Okay, it will be consisting of all the silicate group of minerals that are present in this particular magma. Okay, but right now we are not interested in other constituents of the magma, that is like trapped gases. Also magma has the trapped gases present in it. Then apart from that, some different compositions are also present in the magma. Okay, so but we are interested in the silicate groups. Okay, so as this magma starts getting cooled down, so with respect to temperature a particular mineral starts forming. Okay, so with respect to temperature a particular mineral starts forming. So we'll be seeing which are those minerals and at what sequence they keep on forming. So we'll be seeing them one by one. Okay, so here we are having first mineral in the discontinuous series. Okay, so the first mineral in the discontinuous series which forms is the mineral group that is known as olivine. Okay, it is the mineral group that is olivine. Whatever minerals belong to olivine group, they form at this particular um, discontinuous series, that is the top member, okay, or the first member. So this olivine forms at a temperature, okay. At what temperature does it forms? Whenever the magma reaches a temperature of about 1200 to 1250 degrees Celsius. Okay, so at that time, the first mineral which is going to crystallize belongs to the olivine groups. So olivine is a group. So olivine is a group. So in that we are having different minerals. So for that, whenever the temperature of the magma reaches to 1200 to 1250 degrees Celsius, the first mineral group in the discontinuous series, in the Bowens reaction series, is going to form, that is known as the olivine group of minerals. Okay, so next, when the temperature drops even below 1200 degrees Celsius, okay, suppose the temperature goes up, okay, suppose the temperature goes up to 1200 to 1100 degrees Celsius, 1100 degrees Celsius. So at that time, a different mineral belonging to pyroxene group. Okay, so a pyroxene group of mineral forms. Okay, a pyroxene group of mineral forms at a temperature of 1200 to 1100 degree Celsius. Okay, about 1200 we are getting the minerals which belong to olivine group. So if the temperature even reduces further and comes to about say something 1100 to something 950 degrees Celsius. Okay, so at that time, the next mineral group that is belonging to amphibole group. Okay, that is belong to amphibole. Amphibole group of minerals are going to form at a temperature of 1100 to 950 degree Celsius. So imagine the temperature goes even below to 950 and below that, if the temperature keeps on reducing. So at that time, between 950 to 850 degrees Celsius, the next group of mineral, now I can't call it as a group of mineral, okay, so it belongs to the mica group. So the next mineral known as biotite, okay, the next mineral known as biotite is formed in a temperature of about 950 to 850 degrees Celsius. Means the temperature of the magma has reduced down and has reached to about 950 to 850. So in this temperature range itself, the mineral biotite is going to form. So here, these minerals what you have seen are known as your discontinuous mineral groups. Okay, the minerals belonging to discontinuous series. Okay, so which are the mineral groups belonging to discontinuous series? It is olivine, pyroxene, amphibole and biotite. If the temperature of the magma from about, consider the temperature was about 1400 degrees Celsius. Okay, so from 1400 degrees Celsius, when the temperature reaches 1250 to 1200 degrees Celsius, so in this temperature range only, the first mineral group is going to form, that we call it as the olivine group of mineral. Next, if suppose the temperature goes below 1200 degrees Celsius to between 1100 degrees Celsius, so at that time, the next mineral group belonging to discontinuous series, that is pyroxene, is going to form. Next example, suppose you consider the temperature goes below 1100 degrees Celsius to 950 degrees Celsius, the next mineral group belonging to amphibole group is going to form. Suppose the temperature goes even more less, drops even less. So at that time, if it reaches 950 degrees Celsius to 850 degrees Celsius, so in this temperature range only, the next mineral that is known as biotite, which belongs to mica group, is going to get formed. Okay, so these all minerals what you are seeing are formed in a sequence at a particular temperature what we have written down here. Okay, so this is known as the discontinuous series of Bowens reaction. Okay, this is known as the discontinuous series. Okay, so we'll be coming back to this later. So you can see here this side we have written continuous. Okay, we have written the continuous series. So we have written the continuous series. So in the continuous series, when the temperature goes to about 1200 degrees Celsius to 1000 degrees Celsius. Okay, so in this temperature only the next mineral group that is known as calcium rich. Okay, next mineral that is calcium rich plagioclase. Calcium rich plagioclase is going to get formed. Okay, so in the continuous series at the temperature of about 1200 degrees Celsius to 1000 degrees Celsius, the next mineral that is known as which is rich in a plagioclase group of mineral that is rich in calcium is going to get formed. So next, if you consider here, if the temperature keeps on going below, okay, if it keeps on reducing and reaches up to 1000 degrees Celsius, reaches up to 1000 degrees Celsius to 850 degree Celsius. So in this temperature, the next mineral belonging to feldspar group or plagioclase that is known as that is rich in sodium is going to form. Sodium rich plagioclase. Sodium rich plagioclase is going to get formed. Okay, so next, if the temperature keeps on going down, so before that we will be seeing, so this mineral what you have seen, one, that is this all are belonging to feldspar group. Okay, so here one which is belonging to which is plagioclase which is rich in calcium. Okay, so it forms at a temperature when the magma temperature drops below 1200 to 1000 degrees Celsius. So consider if the temperature goes down even less, so at the temperature of 1000 degrees Celsius to 850 degrees Celsius, the next variety of plagioclase that is which is rich in sodium that is going to get formed at this particular temperature. Okay, so this is known as your continuous series. So here you can see this is a discontinuous series, this is a continuous series. So why as continuous series? Because here we can see the minerals that belong to only plagioclase, those are getting formed. Okay, the minerals that are belonging to plagioclase group, only those minerals are getting formed here. It might be one is calcium rich plagioclase, here it is sodium rich plagioclase, but here all the mineral groups are different. Olivine group is a different mineral group, pyroxene is a different group of mineral group, amphibole is a different mineral group, and biotite it belongs to some different mineral group that is mica. So this here all are different mineral groups, but here it is only one single mineral group that is belonging to plagioclase. Okay, plagioclase. So here we will be seeing these minerals between plagioclase and sodium. Okay, that is calcium rich plagioclase and sodium rich plagioclase, there are different minerals that are going to form. Okay, so we'll be seeing those minerals one by one. So here I'll be making use of mnemonics. Okay, I'll be making use of mnemonics. So the mineral which is forming here, I will be writing it here, that is anorthite. Anorthite. Okay, so after anorthite, next mineral that is going to form is bitonite. So after bitonite, next mineral that is going to form is labradorite. labradorite. Next mineral after labradorite that is going to form is andesine. After andesine, we are having oligoclase. And after that one, we are having next mineral that is going to form, that is albite. Okay. So between this calcium rich plagioclase and sodium rich plagioclase, there are various minerals those are going to get formed. The temperature of this ranges from 1200 degrees Celsius and 1000 degrees Celsius. Means what? Between a temperature of 1200 degrees Celsius and about 815 degrees Celsius, these all sequential minerals are going to form, which are nothing but minerals belonging to your continuous series. So in some Bowens reaction series, they just write calcium rich plagioclase and sodium rich plagioclase. But in calcium rich plagioclase and sodium rich plagioclase series, between that, these all minerals in sequence they are going to form. So you have to write these minerals in sequence. So if you want to write these minerals in sequence, you have to make use of some things, that is some tricks. So I use mnemonics here. I use this first term O, P, A and B. Okay, so using this first alphabets of each minerals, I can make some mnemonics, that is old, people, are, best. Okay, old for olivine, people for pyroxene, R for amphibole, best for biotech. Okay, so if I use the mnemonics and make the things understandable, it can be easily remembered by me. Okay, so that will turn out very helpful for you to write in the exam and know the series as well. Okay, in the proper sequence. So here, what can I make the mnemonic as? I'll be using this first terms, alphabets, A, B, L, A, O and A again. So what can I make out of this? That is unoccupied land area outside America. Okay, so unoccupied land area outside America. Okay, so Anand for anorthite, bide for bitonite, land for labradorite, area for andesite, outside for oligoclase, America for albite. Okay, so that will give me a sequential way how the minerals are going to get formed in the continuous series. So it is very easy for me to understand. So this anorthite should actually come here. That is, it is nothing but 100% calcium rich plagioclase, and wherever the plagioclase is 100% consisting of 100% sodium, we call it as albite. Okay, so this is the minerals between a form between calcium rich plagioclase and sodium rich plagioclase. So this is your continuous series and this is your discontinuous series. We have discussed why this is known as this is known as continuous series and why this is known as discontinuous series. Okay, so these two series they come and meet at a particular point. Okay, so at this particular point, the next mineral that is going to get formed, the next mineral that is going to get formed, that is nothing but known as your K feldspar. Okay, it is known as K feldspar, also known as orthoclase. At what temperature does it form? It forms at a temperature of about 800 degrees Celsius. It is approximate temperatures. Okay, so at a temperature of about approximately 800 degrees Celsius to 750 degrees Celsius, when the temperature of the magma drops to this temperature, the next mineral what is going to form is known as your potassium feldspar, also known as your orthoclase. Okay, so suppose if the temperature goes even less below this of the magma, if the temperature of the magma keeps on reducing, so if it reaches a temperature of about say 700, okay, so if it reaches a temperature of about 750 degrees Celsius to 700 degrees Celsius. So at that time, the next mineral belonging to mica, that is known as mica group, that is known as muscovite, that is known as muscovite is going to get formed. So imagine now the temperature of the magma has gone down. Okay, so the temperature of the magma has even gone down and reach up to something. I will take it for here 573 degrees Celsius. Okay, so 573, or I can write approximately 700. I will write approximately 700 700 degree Celsius. So if it goes the temperature of the magma to this temperature, so at this temperature the next mineral that is known as quartz is going to get formed. Okay, so simultaneously if the temperature keeps on reducing, the next mineral that is known as zeolites are going to form, zeolites. So after that, once everything is taken out from the magma, whatever remains is nothing but a hydrothermal solution. Okay, so this is what it forms at the last. Okay, so hydrothermal solution is nothing but hot water. Okay, it is nothing but the hot water. So just imagine the process of making tea here. Okay, just will imagine the process of making tea. So while making tea, what we do, we add different ingredients to it. So first we add water, then we add uh, tea powder, then we add milk. Okay, so this is how we make, and we keep on boiling. So just imagine this thing that is making the tea in a reverse order. So what we will do, once the tea is prepared by making all this thing, so once the tea is prepared, what we have added, we have taken water, to that we have added tea powder, to that we have added boiled for a while, then we added milk. So we'll keep on removing the ingredients from this. So if we take out the milk, so what will happen, the tea will look somewhat mm, brownish. Okay, so if we take out the tea powder also, what is going to happen, so it is going to look just a boiling water. Okay, so consider this magma consisting of all these elements. Okay, magma consisting of all these elements. So one by one, if they keep on crystallizing out of magma, so finally what is going to be left, it is nothing but hot water. So from the tea example you can understand that if you take out all the ingredients from the tea, like whatever milk you added, whatever tea you added, whatever is left at the last is nothing but the hot boiling water. So that is nothing but the case here. After you take out everything from this particular magma, they keep on crystallizing at a particular temperature, means what will happen, those that magma is getting depleted, that thing is getting removed from that magma. So finally what is left is nothing but in the magma is that only hydrothermal solution. Okay, so this Bowens reaction series is very much useful in understanding what is the sequential crystallization of the minerals. So here I have written the temperature from 1400 to I will write it near about 573 degree quartz will crystallize. Okay, I've written here 700, no issues. So after that, below this temperature, your zeolite and hydrothermal solutions are going to get formed. Okay, and finally it is hydrothermal solution means nothing, it is just a hot water. Okay, so you have to keep in mind this all minerals from here to here. Okay, so this all minerals from this side to uh, this side. Okay, and even this minerals, and even this minerals Even these minerals on this side are nothing but your high temperature minerals. They are high temperature minerals. Okay, they are high temperature minerals, and also they are um, mafic. They are ultra mafic to mafic in composition. If you take olivine, it is ultra mafic. So I can write it mafic, ultra mafic to mafic in composition. Okay, so if you come here, this all minerals from here to here. Okay, so this all minerals from, I will write it one more time. This all minerals from here to quartz. Okay, so these all are low temperature minerals. These all are low temperature minerals. These all are low temperature minerals and are felsic or acidic minerals. Okay, and also they are rich in silica. Rich in silica. This one here are poor in silica. This one here, they are poor in silica. Okay, so this is all about the Bowens reaction series. So I will just about this. So what we have seen here. So this Bowens reaction series is very much helpful whenever you are studying the igneous petrology, and it will be used in one or the other way to know the sequential way how the minerals are getting formed. So for that, you have to keep the minerals in the mind, in the sequence how they are going to get formed. The Bowens reaction series has been divided into two types, two series. That is, one is a discontinuous series and one is a continuous series. We have discussed why we call one as the discontinuous and one as the continuous series, because here different in the discontinuous series different mineral groups are forming like pyroxene, olivine, amphiboles. Okay, and here in the continuous only one group of mineral, that is plagioclase, a group of minerals or the feldspars are forming, that is ranging from the calcium rich plagioclase to the sodium rich plagioclase, and definitely remaining things we have discussed. So this is all about your Bowens reaction series. So I hope you have understood this series and why it is used, and it helps how it helps in understanding the mineral crystallization. Okay, so with this one I will be ending this lecture. Okay, so thank you.